Start. Okay.
Sige, Patricia, go.
And good afternoon po ulit sir and classmates. We are group number 3 po and we are to discuss properties of solid, liquid, gaseous fuels except po yung alternate fuels. Ako po si Patricia Marcelo and didiscuss ko po yung solid fuels muna. So, properties of solid fuels. Let's discuss po muna yung ultimate analysis. Provides the major elemental composition of the coal, carbon, hydrogen, oxygen, nitrogen, and sulfur by weight. American Society for Testing and Materials ASTM D3176 discuss the procedure on how to obtain the said values. The analysis may be reported as gravimetric analysis or volumetric analysis. So dito po sa ultimate analysis, we try to determine the different components ng fuel or coal, for example, by its content. Yun nga po yung carbon, hydrogen, oxygen, nitrogen, and sulfur. So, pag po pala pinerform or ginawa tong ultimate analysis, it cannot be done in a simple setup like yung laboratories po sa ating universities dahil it needs a certain equipment or materials and it can only be performed by a professional or skilled scientist or chemist. Next, Amel. So, ito po yung two types po na pwedeng gawin under ultimate analysis. Yung gravimetric analysis po reports the percentage composition of coal in mass basis. So, dito po sa gilid, yung formula. Gravimetric analysis po, it focuses on the mass fraction of the different components of a fuel or coal, kunyari. And which ang formula po niya is X sub I equals M sub I over M sub T, where X sub I po is the component of the coal or fuel, and M sub I is the mass of the component, and M sub T is the total number of mass. Then, yung next naman pong analysis is volumetric analysis, reports the percentage composition of coal in molal basis. Pabalik ako nga. It focuses naman po sa mole fraction, and yung Y sub I is the percent mole of the component, and the N sub I is the number of moles, and N sub T is the total number of moles. Ayan po.
Report, anong pangalan?
Patricia Marcelo po, sir. Marcelo
Patricia,
po.
may mga sample ka dyan mamaya? Oh, may parang sample.
Apo, sir.
Sige.
At the end po.
Sige.
Apo, mga pagkatapos po ng lahat ng ano. Sige po. Yan. Mole is defined as the mass of a substance equal to its molecular mass or molecular weight. So, to determine the mass of a component, mass is the equivalent to the number of the mole and multiplied with the molecular weight, where M is into kg is the mass of the component, and N in kmol is the number of moles of the component, and M in kilomole is the molecular weight of the component. So, and next nga, Camille. Ito po yung table ng sample po ng mga commonly used elements. Ayan po, hydrogen, oxygen, nitrogen, carbon, and its molecular weight and atomic weight. Ayan. So, next analysis naman po is yung proximate analysis. Determines the moisture, volatile combustible matter, fixed carbon, and ash by percentage weight through ASTM D3172. So, dito po sa proximate analysis, unlike po dun sa ultimate analysis, pwede po siyang gawin sa laboratories with the right equipments po. And unlike din po sa ultimate analysis, mas low po kasi yung accuracy nito. Unlike dun sa ultimate analysis na may mas high yung accuracy in terms of pagkuha ng mga ng fuels like coal. Next ako, Amel. Next. So, ito po yung procedure ng ASTM sa pagkuha po ng um, ng coal. So the first step po is the coal is crushed. Then second step po is after po makrush yung coal, it is dried in an oven at 105 to 110 degrees Celsius to determine the residual moisture. So after subjecting the coal to this temperature po, mag-evaporate po yung moisture, and pag nag-evaporate po yung moisture, there would be a change in its mass, and from then final mass, which determines the amount of moisture po. So sa next step naman po, so sa second step po pala nakuha ni moisture content. Then sa third step, kukunin na po yung volatile matter. So heated in a crucible at 900 degrees Celsius to determine the volatile matter. Same goes with what happened po sa second step. Yung matitira pong mass, kukunin lang po yung difference ng initial saka ng final mass to determine the volatile matter. So, last step po ang kukunin naman po ay ang fixed carbon. So, the remaining sample is heated in an oven at 750 degrees Celsius without cover to determine the fixed carbon. This is the ash content. Ayun po. Sir, meron po kaming video na pagkuha po ng proximate analysis. Okay lang po ba i-play? Po. Opo, sir. Wala po noon ultimate analysis eh. Opo.
Hello, my dear student. I would like to introduce myself. I am Tushar Chandra Ganguly. Okay. So, जो भी आपके केमिस्ट्री के प्रैक्टिकल है,
Ito na ba yan?
Okay po. So, let's talk about the different components naman po yung kinukuha po kanina sa proximate analysis. Yun nga po yung moisture content, volatile combustible matter, saka fixed carbon. So, moisture content is the amount of water contained in the fuel. It is the combination of water existing as water vapor, liquid water chemically bound to the fuel, and free liquid water within the pores of the solid fuel. So, according nga po dito sa definition, there's not only one type of water when we're trying to determine the moisture content kasi meron pong iba't ibang types na nag-exist sa isang single coal or single fuel. So, yung water existing as water vapor po, it can be removed by air drying. Then, yung free liquid can be removed by heating coal above 100 degrees Celsius. Samantalang yung liquid water, chemically bound to the fuel naman po, ay can't be removed even through heating dahil nga po nakalagay dito, it is bound to the fuel, which means it cannot be separated. So, next po is yung volatile combustible matter. Is the gaseous phase, condensable and non-condensable, formed from the thermal degradation of the fuel. If the fuel has high volatile combustible matter, the fuel ignites easily. So, yung pagkuha nga po nung volatile combustible matter, gaya ng sinabi kanina, the ash should be in a covered crucible. Next po is yung fixed carbon, is the portion of the coal that remains after the devolatilization process. It is the amount of solid carbon that must be burned in a coal. The fixed carbon helps in the selection of the combustion equipment as it indicates the caking properties of coal. So after fixed carbon is removed, there could be two products. Yung una po is yung coke, and it is pabalik muna ako. Ayan. It is the hard porous residue and almost pure carbon. After yung coal is devolatilized, and yung next one naman po is yung char, and it could be known when the residue is powdered. And fixed carbon din po is a huge factor to determine the energy produced by a certain fuel. Ayun, next namin. Next is ash content. It is the inorganic residue remaining after the fuel is completely burned. Ash characteristics should be considered in system design in order to minimize slugging, fouling, erosion, and corrosion. So the composition of fuel is reported on an as received basis or on as dry basis or on a dry ash free basis. So mamaya po magagamit po tong formula na to sa pag-solve ng mga sample problems. Ayun po. Next. Yan. So, heating value, the amount of heat liberated per unit of mass of fuel when it is heated at high temperature in the presence of oxidizer. The heating value is determined in a bomb calorimeter in ASTM D5865 at constant volume. Next, yan. So, there are two kinds of po ng heating value, yung higher heating value and lower heating value. So, higher heating value is also known as the gross calorific value. It's when the fuel burned has its water in liquid phase. In this case, the amount of heat vaporization is accounted. Lower heating value or the net calorific value is when the fuel burned has its water in its vapor phase. Thus, heat of vaporization is not considered. So, ayun po yung pagkakaiba nila. When the fuel is burned po sa higher heating value, nasa liquid phase po siya, while may liquid heating value naman po ay nasa vapor phase. Ayun, next, Ayan po yung table, yung example po ng mga pag-approximate analysis po sa ultimate analysis. So, ayun po. Yung percent lang po, sir, nung mga element, po. Ito po yung volatile, So, grindability determines the relative ease of pulverization of coals and determined by ASTM D409, and the result is known as the hard grindability index or HGI. The smaller the value of HGI, the less it is grindable. This parameter allows for the estimation of the grinding power requirements of the mill. So, yung grindability test po is a procedure that evaluates the resistance of a metal to a ball milling. Yung ball milling naman po is a grinding method that grinds nanotube into extremely fine powders. Ayun. So, free swelling index is an indication of the caking characteristics of coals when burned as fuel. It is determined using the procedure indicated in ASTM D720. The high FSI is likely to be used as a coking coal, fuel for production of steel, while low FSI coal is used as the fuel in steam power generation. So, lastly po, yung ash fusion temperatures is the temperature where the ash has reached a softened state and has a tendency to foul boiler tubes and surfaces. This temperature is determined using the ASTM D1857 procedures. It should be noted that the ash fusion temperatures is typically below the flame temperature but above the steam and wall temperatures, which results in fouling and slagging. So, yung properties of liquid fuels po to be discussed by Brian Bernardo po.
Test. Can you guys hear me? Hear po ba ako? Hello? Start ka na. Properties of liquid fuels. Next slide. Unlike solid fuel, where composition differs, crude oil chemical composition is roughly made up of 80% carbon, up to 3% sulfur, and up to 0.5% nitrogen and 0.5% oxygen. With the remainder primarily hydrogen. This means that crude oil or petroleum is made of hydrocarbons. Speaking of hydrocarbons, a hydrocarbon is an organic chemical compound composed exclusively of hydrogen and carbon atoms. Hydrocarbons are highly combustible and produce carbon dioxide, water, and heat when they are burned. Therefore, hydrocarbons are highly effective as source of fuel. Okay, next slide. All of the non-liquid type that we have is derived from crude oil as it undergoes the refining process. It starts off with the fractional distillation process where the crude oil is vaporized at 600 degrees Celsius. The vapor passes through plates at different temperatures and condenses the vaporized crude oil. Straight run gasoline condenses at low temperature while kerosene, diesel, and other forms of fuel condenses at higher temperature. The other processes to refine the distilled crude oil are as follows. Uh, Cracking consists of breaking down large complex hydrocarbons molecules into simpler compounds. There are two types. There are two different methods to what do you call this? To do cracking. First is thermal cracking. It is cracking with the use of temperature, kasi sabi doon thermal, yeah. And catalytic cracking. Catalytic means it needs catalyst to do cracking. Yeah. Next. Hydrogen Hydrogenation is the process of adding hydrogen atoms to the hydrocarbons at high temperature to produce more stable compounds. It is usually used in fats and oils industries, especially in margarines production para maging stable yung oils ng mga products. Okay, next. Polymerization. Process of converting olefins, the unstable products of cracking, into heavier stable compounds. Polymerization happens when monomers combine to produce huge chain-like molecules called polymers, which polymerization came from. Examples of products ng polymerization are plastics, rubbers, and adhesives. And next. Alkylation combines an olefin with an isoparaffin to produce a branched chain isoparaffin in the presence of a catalyst. Alkylation is done to produce high-octane components of gasoline. It is a type of gasoline that allows engine to have high compression ratios, meaning the machine will be able to extract more energy from the combustion process. Next. Isomerization changes the relative position of the atoms within the molecule of a hydrocarbon without changing its molecular formula. Example is the conversion of butane to isobutane. It is done by heating the butane to 100 degrees Celsius with the presence of a catalyst. Okay, next. Cyclization brings together the end of a chain molecule to form a ring compound of the naphthalene family. As it said sa name, cyclization, nagsicycle yun, kaya nagpo-form siya ng ring. Next. Aromatization. Join together the ends of a strain molecule to form a ring compound of the aromatic family. It's very, very simple lang din siya. Nag-join together lang yung ends of straight chain molecules para makagawa ng ring compound. Okay, next. Reformation, a type of cracking process which is used to convert the low antenna quality stocks into gasoline of higher octane rating. The higher the octane rating, the better for the machine because yung kaya naman sabi ko kanina din sa alkylation, yung mas mataas na high octane rating, mas high compression para sa mga machine. Okay, next. Blending, a process of obtaining product of desired quality by mixing certain products in suitable proportion. Yeah. It is done by simply blending the materials and the products. Okay, next. Ito po yung examples ng oil refinery products. Okay. Next. This is the table po yung boiling range and yung remarks po ng. Okay, next. Types of liquid fuels. Gasoline is a blend of alkanes, cycloalkenes, and aromatics which varies slightly at different refineries. Due to different blend, there is range of amount of carbon available. The chemical composition may vary, but it is generally known as isooctane or C8H18. Next. Diesel. It is a mixture of C10 to C15 hydrocarbons with a higher point range than gasoline. There are different grades of diesel fuel with varying applications. Grade 1D is a distillate fuel which mostly for light trucks and buses. Grade 2D is a middle distillate fuel for highway speed engines. And grade 4D is a heavy distillate fuel used in low speed industrial and marine diesels. The average chemical formula is C12H24. Okay. Fuel oil. Heating covers a wide range of petroleum products and are divided into 6 different grades with a omission of grade 3 due to its rare application. Okay, next. Naphtha. A mixture of volatile liquid hydrocarbons that are used as feedstock for other products including gasoline. Yung feedstocks are yung products para mag-catalyze yung para mag-produce ng gasoline. Ang example niya is crude oil. Okay, next. Typical properties of fuel. Ito po yung table. So you can see. Specific gravity. It is the density of fuel divided by the density of water at the same temperature. For liquid fuels, the standard is to use the Baum scale. Ito po yung Baum scale, yung 140 over SG of 15.6 degrees Celsius minus 130. Kasi yung PI po ito. Tapos yung CF po, ginagamit siya pagka ginagamit po siya pagka hinahanap pag po hindi yung 15.6 or yung 60 degrees Fahrenheit yung given dun sa para po yung ibig sabihin po kasi ng CF correcting factor. Next. Heating value. The heating value is amount of heat or energy liberated by burning the fuel. ASTM D4-868-17 is the standard method test for estimation of the net and gross heat combustion of hydrocarbon burner and diesel fuel. But there are certain equations that can be used for approximation. Ito po yung formula for petroleum products. Yung given po itong mga number dito. Okay. Next.
Formula yan? 4113? Oh, ganun.
Opo. Sa petroleum products po.
Kunin niyang degrees.
Yung yung given po nung yung dun po sa Baum po. Yung pag po kailangan po kasi lagi po siya 15.6.
May given na dyan sa degrees.
Opo.
Ayun, yung 14.
Opo.
Di ba yun, 141.5 divided by specific gravity at 15.6 degrees centigrade? Okay.
Okay, next. Heating of charge. This is the amount of heat that must be supplied to obtain a certain air vapor mixture consists of 3 parts. 1. Heat to raise the temperature to the equilibrium temperature. Number 2. Heat to raise the fuel temperature to the same temperature. And lastly, latent heat of vaporization of required part of the fuel. Okay. Viscosity. It is the measure of liquid resistance to flow. And it indicates the ease at which the fuel can be pumped and optimized. Okay. Next. Volatility is the measured by Reid vapor pressure, which is equilibrium pressure exerted by vapor pressure over liquid at 37.8 degrees Celsius. It affects engine startup and transient performance as well as evaporate emissions during filling. Yung katulad nga po na sinabi kanina ni Patricia, yung the higher the volatility, mas mas marami pong parang waste yung product po na yun. Okay. Next. Flashpoint. It is the indication of the maximum temperature at which liquid fuel can be stored and handled without serious fire hazard. Ito po yung, kunwari po yung parang pagka lumagpas po sa flashpoint, pwede pong mag-combust yung fuel. Okay. 4 point. It is the lowest temperature at which fuel oil can be stored and still be capable of flowing under very low forces. What will happen po kasi if pag po sumobra na po yung baba, hindi na po magpo-pour po ng maayos yung fuel, magiging viscous na po siya at makaka-affect po siya sa performance po ng machine. Cloud point. It is the lowest temperature at which fuel will start to form crystals. Ayun po yung para pong mag-freeze po ng dahil po sa low temperature. Okay, next. Auto-ignition temperature. It is the lowest temperature required to initiate self-sustained combustion in a standard container in atmospheric air in absence of spark or flame. It is the indication of the relative difficulty of combusting a fuel. Due to the various factors affecting the determination of the auto-ignition temperature, octane and cetane numbers are used. Ito po yung the lowest temperature para po mag-self-combust po yung fuel. Okay. Octane number indicates the tendency of gasoline to knock or onset of auto-ignition. When the compression ratio in a spark ignition engine is raised, it is measured by comparing the fuel performance against the performance of isooctane-heptane mixture. The greater the octane number, the greater the anti-knocking property of the gasoline. Just like what I said earlier po, the higher the octane number, the better for the machine po kasi mas mataas po yung magiging compression ratio po ng machine. Okay na. Cetane number ranks fuel according to their ignition delay when undergoing compression ignition. The cetane number is measured by comparing the performance of diesel fuel against the cetane and hexadecane and isocetane or heptamethylonate mixture performance. Performance refers to the ignition delay and is the time between the start of injection and the onset of combustion. Ano lang po siya, ginagamit po siya para po yung para po ma-compare po yung para po pang-measure po siya para po makuha po yung auto-ignition sa temperature po. So, ginagamit po yung octane number tsaka po yung cetane number. Okay, next po. Yun lang po, para sa liquid fuels. In next na po, magre-report. Discussion about the properties of fuel. Mag-move on naman po tayo sa gaseous fuel.
Next mo pong present po sir si Ian Miguel Mariscotes po. Wait lang po at nagkakaroon na po ng konting mechanical difficulties po. Play ko lang po uli yung, may play lang po palang video tungkol po sa diniscuss po ni Brian kanina. Ito po ay tungkol doon po sa refining po ng petroleum.
Refining begins with a process called distilling. After oil is superheated, it becomes vapor. The vapor is fed into the distillation unit. As it rises and cools, the vapor turns back into a liquid. Using stacks of trays, the liquid is easily collected and separated by weight. The lighter and medium weight liquids require less processing before they're ready to be used in cars and trucks. The heavier liquids need more processing to become useful. A process called cracking is used to maximize the usefulness of heavy oil. Heavy oil has long strings of carbon and hydrogen molecules. Using a catalyst, these molecules can be broken into smaller chains, transforming the heavy oil into lighter, more valuable fluids. Reforming is a process that increases the amount of gasoline produced from crude oil. One of the products separated in the distilling process is a liquid called naphtha. The number of carbon atoms in naphtha is about the same as the number found in gasoline, but their structure is more complex. Reforming rearranges the naphtha molecule, turning it into a usable, gasoline-like molecule. Blending is a process of mixing different refinery products to make finished petroleum fuels. Gasoline, for example, is blended to achieve octane standards, creating the grades of gasoline you see at the pump: regular, mid-grade, and premium, that are necessary to meet the needs of specific engine types. Treating is a process used to produce cleaner gasoline, which helps protect both the environment and our health. Gasoline molecules contain impurities like sulfur that can be removed. When the molecules are heated and come in contact with a special catalyst, a chemical reaction occurs that strips the sulfur away. These sulfur compounds are used as fertilizers and in pharmaceuticals. Nothing goes to waste in a refinery.
Ngayon naman po, to continue the discussion about the properties of fuel. So the properties of fuel, usually yung mga gaseous fuel, next, usually yung mga gaseous fuel ay yung gases na may fixed composition such as acetylene, C2H2, methane, CH4, ethylene, C2H4, and ethane, C2H6. Next. Ang example ng mga gaseous fuel ay yung mga composite industrial gases. Ang example niyan is yung blast furnace, coke oven gas, producer's gas, blue water gas, and many other more. So to discuss yung advantages and disadvantages ng gaseous fuel, let's first start sa advantages niya. Gas can be produced at one point and clean gas is distributed over a wide area kung saan pwede siya magamit sa iba't ibang purposes. Next is yung combustion of gaseous fuels permits the exact control in quantity, yung haba ng apoy, yung nature ng apoy kung reducing or oxidizing, and nakakontrol din yung temperature. Yun yung isa sa mga advantages niya. Then next is yung smoke and ash ay eliminated since unlike solid fuels, wala siyang solid na body na binaburn. Then next is yung greater economy in high temperature work and efficiency ng furnace. So para hindi na pahabain, next naman is yung disadvantages. Sa disadvantages naman niya, dahil gas siya, between liquid and gas, ang mahirap i-contain is yung gas. Kasi yung property ng gas is, di ba, kalat-kalat. Mas dense ang liquid. So, kailangan ngayon ng gas ng specialized na container, and usually, mas malaki yung kailangan. Dahil mahirap siyang i-transport sa mga piping systems. Next. So to further discuss the gaseous fuels, discuss natin yung types niya. And yung una is yung natural gas. Natural gas usually found in compressed porous rock and shale formations sealed in rock strata below the ground, which is used for domestic and industrial heating. So usually, nahahanap siya sa upper part ng petroleum field under sa lupa natin. And usually, mixture siya ng hydrocarbons, example, methane, and lesser amount ng ethane, propane, butane, and pentane. Nagko-contain din siya ng mga non-combustible gases like carbon dioxide, nitrogen, and helium. Pero pwede naman silang ma-remove by processing yung natural gas at meron siyang calorific value na 30 megajoule per cubic meter. Next. So, methane, example niyan is yung makikreate siya sa mga landfills by methanogenic bacteria. So, ano nga ba yung methanogenic bacteria? Siya ay nagdi-decompose ng organic materials para magkaroon ng carbon dioxide at methane. Less soluble siya sa water and mas magaan siya kaysa sa air. Pwede rin siyang collect at mailagay sa mga tubo. Dahil sa greenhouse gases, yung methane, example siya niyan, for environmental purposes, dapat na nililimitahan yung paggamit ng gaseous fuel na to. Next is liquefied petroleum gas. It is a variety of gases which is produced by processing natural gas. It is a combination of ethane, propane, butane, and it is also a byproduct of refining crude oil in its form of ethylene, propylene, and butylene. Next. Next is yung syngas or yung tinatawag nating coal gas or town gas. So yung syngas, ay mali pala, producer's gas pala yung syngas. Usually created siya ng by passing a less than stoichiometric amount of air and oxygen through a hotbed of coal or biomass particles. The process to produce syngas is known as gasification. So yung producer's gas, na-obtain siya sa partial combustion ng coal, coke, or peat. Kapag nasunog sila, may insufficient amount ng quantity ng air and usually ginagamit sila sa steel industries para sa firing open ng furnaces. Next. Next is yung hydrogen. Nakukuha siya by reforming yung natural gas, also partial oxidation ng liquid hydrocarbons, or pag-extract sa mga syngas. It can also be produced by decomposition of water through electrolysis. And electrolysis is an attractive method of producing hydrogen because it will not produce carbon dioxide emissions. Next. Next is yung coal gas or town gas. Usually, binubuo lang siya ng hydrogen, carbon monoxide, and hydrocarbons. And nabuo siya by carbonization of coal. Ito yung ginagamit ng industry sa pagpapailaw dati or sa pagluluto ngayon. Next. Coke oven gas. So yung coke oven gas, na-produce siya dahil sa pag-heat or coke oven gas is produced during production of coke by heating bituminous coal at 600 degrees Celsius to 1000 degrees Celsius. So ang characteristics ng coke oven gas, pareho lang siya sa coal gas na na-discuss kanina. Next. Blast furnace gas, nakukuha siya by a byproduct of during manufacturing of pig iron. So to discuss, ano nga ba yung pig iron? Pig iron is also known as crude iron. Ito yung iron na kapag in-smelt sa blast furnace. The gas leaving the blast furnace has high dust content, which must be removed by dust collectors and washing operations. Blast furnace gas also has low calorific value and usually used for metallurgical furnaces. So metallurgical furnaces, yun yung mga device na nagpapainit or nagme-melt sa mga metal ore. Usually sa mga iron or tsaka sa mga steel production. Next. Next is yung heating value. As discussed kanina, yung heating value is the heat released per unit mass when the fuel initially is at 25 degrees. Pag nag-react siya sa oxygen, at kapag yung product ay bumalik sa 25 degrees Celsius. So ang formula niya is the low heating value is equals to high heating value minus the mass of the water divided by the mass of the fuel multiplied by the latent heat of vaporization of water at sa reference temperature natin na 25 degrees Celsius. Usually, ang value niya is 2,440 kilojoules per kilogram ng water. Next po. Next naman is yung typical heating values of gaseous fuels. Diyan makikita natin yung list of fuels, high heating value and low heating value nila. Ang unit nila is megajoule per cubic meter or megajoule per kilogram. Next po. Next is the auto-ignition temperature. The auto-ignition temperature of alkenes ay nagdi-decrease habang tumataas ang molecular weight. Ang example niyan is yung methane at 537 degrees Celsius, ethane at 472 degrees Celsius, and propane at 470 degrees Celsius. So yung auto-ignition temperatures, dependent siya sa geometry ng surface na mainit and also yung pressure na na-experience niya. So to discuss yung auto-ignition temperature is the lowest temperature at which the fuel will spontaneously ignite in a normal atmosphere without an external source of ignition. So ano nga bang pinagkaiba niya sa flash point? Ang difference nila ay yung flash point, dinedetermine niya yung lowest temperature at which yung vapor ng material start na mag-ignite in the presence of an ignition source. Ay naman, ang ignition temperature is the lowest temperature at which a material can start ignition spontaneously. Next. So additional lang dun sa mga naunang properties ng fuel, yung solid liquid gas. Since renewable energy in demand siya ngayon to replace yung mga fossil fuels na usually na standardized na ngayon. Ito yung mga ibang examples niya. Next. Next pa. So yung solid alternate fuels, next. Ang example niya is yung biomass. Nagre-refer siya sa range ng organic materials na na-produce sa mga halaman or sa mga waste ng animal na nag-feed dun sa mga halaman. Ang examples niya is yung mga tuyot na dahon na nalaglag, yung mga poop na mga animals, at saka yung mga nakolektang waste sa industry natin. Next. Liquid alternate fuels. Ang mga examples niyan is yung una, alcohol. So bakit nga ba siya maganda or nakaka-intriga kasi na-obtain siya from both natural and manufactured processes. So, yung natural niya, usually sila yung mga ethanol, propanol, and butanol. And kapag manufactured naman sila, yung bioalcohol, may high octane rating and nagpo-produce siya ng less overall emissions compared sa mga gasoline. Next is yung biodiesel. Biodiesel, nagre-refer siya sa mga vegetable oil or animal fat na diesel. Doon siya nag-base. Nagko-consist siya ng long chain ng alkyl esters. Biodiesels is typically produced by chemically reacting lipids with alcohol. Dahil nga fats yung pinag-uusapan, yung lipids yung commonly na pinag-aaralan dyan. Yung oils niyan na napoproduce ay yung virgin oil, feedstock, animal fats, algae, pure plant oil, or straight vegetable oil. Next naman is yung alternate gaseous fuel. So, pinaka-common dito sa country natin is yung biogas. Usually, yung biogas sa mga may-ari ng mga babuyan kasi doon malakas yung pag-produce ng mga poop ng mga animals. So, paano nga ba nabubuo yung biogas? Nabubuo siya through anaerobic digestion ng mga poop ng animals. Then, kino-convert lang siya into usable fuel. So, to further discuss naman po yung mga formula na pag-usapan kanina, magbibigay po kami ng sample problems. And yung una po is for the solid fuels.
Good afternoon po. Sample problem number 1. Determine the mole fractions of a gas consisting of a mole of oxygen, 8 moles of nitrogen, a mole of carbon dioxide, and 2 moles of carbon dioxide. Determine also the mass fraction. What is the average molecular weight of the gas? So, dito po sa solution natin sa problem number 1, una pong kinuha, first sinulat muna natin, wait lang.
Anong problem yan?
Sa mole po. Ito po, mole fractions po.
Anong analysis yan?
Yung pinakauna po, na yung kay Patricia po na part, yung pag-aalam po nung sa mass fractions po.
Okay.
First, sinulat muna natin yung mga given, which
Sige.
the...
May mouse ka ba? May katulong mo ba yan sa mouse?
Ito po, ayan. 1 mole of the oxide. The nitrogen is 8 mole. Then carbon dioxide is 1 mole. Carbon dioxide is 2 mole. Then first kinuha po muna natin yung total nung sa N.
Pwede mo bang lakihan yan? Lakihan? Pwede ba? Kaya ba yan? Lakihan?
Ayan po.
Yan. I-focus mo para yan. O, nasan ka? Nasan ka ngayon?
Ito po.
O, ano ibig sabihin
Kita po
yan?
ba yung mouse pointer? Ito po yung, kinuha po muna yung total N or yung mole of
Mole ba yan? Total mole?
Yes po. Mole po.
Okay.
Mole of the given, which is 1 plus 8 plus 1 plus 2. The total po niya is 12. Then next is, kinuha po natin is yung mole fraction oxygen. Mole fraction po muna ng oxygen. Focus po muna tayo sa oxygen ngayon. Then yung given na 1 mole ng oxygen is i-divide lang siya sa total of the mole we got, which is 12 mole, and we multiply sa 100% to know kung ilang percent yung mole fraction ng oxygen sa kabuuan. So 1 divided by 12 is times 100% is equal sa 8.33%. Then, ganun din sa nitrogen. Ilan po ang nakuha natin sa nitrogen? 8 mole po. Then, i-divide lang po natin siya sa total, which is 12, and multiply to 100%, which is with the total of 66.67%. Sa carbon monoxide, ganun din po. 1 mole is the given for the carbon monoxide. Divide lang po sa total nilang lahat na 12 moles times 100%, 8.3333%. Then, mole fraction of carbon dioxide, ganun din. 2 moles ang given ko sa carbon dioxide. dividing it to 12 moles, then multiply it to 100%, which is 16.6667%. And pag tinotal po natin lahat na nakuha po natin percentage ng mole fraction, we could get 100%. Yeah, 100%. Then next naman is the molar mass. Ang formula po natin is yung nakuha po nating N, the mole, is ito yung 1 mole, 8 mole. I-multiply natin siya sa molar mass para makuha yung mass mismo ng oxygen. Mass mismo ng mga elements na hinahanap. So, example, dito sa oxygen, given po natin is 1 mole. Then, sa oxygen, ang molar mass niya is 16. Since diatomic ang oxygen, multiply natin siya sa 2 with so 16 times 2 is 32 times 1, 32 grams. Then, ganun din po sa nitrogen, diatomic din po siya, ang molar, ang ano po niya is 12. Then, dahil diatomic, multiply lang po sa 2. Then, multiply sa mole niya, na given, which is 8 mole, getting 224 grams. Then, sa carbon monoxide, 1 mole. 1 mole yung carbon monoxide. Then, carbon, ang ano niya is 12. Then, yung oxygen, since di naman naka-indicate na 2, 1 lang ang oxygen sa carbon monoxide, 16 lang. Hindi siya i-multiply sa 2. So, 12 plus 16, i-add lang yung mass nung sa molar ng carbon net oxygen. 12 plus 16, we get 28. Since multiply lang naman sa 1. Then, sa carbon dioxide, 12 sa carbon, dahil diatomic, indicated na diatomic ang oxygen dito, 16 times 2. So, 12 plus 16 times 2, then multiply sa 2 na given us the mole, we get 88 grams. Then, after we get all of this, the 32 to 224, 28, 800 grams, 88 grams, we get the total of them getting 372 grams. Then, after that, after getting the total, we get the mass fraction. The mass fraction. Parang yung kanila din po sa mole fraction. In this case, yung mass lang nung per element divided by the total mass of the total mass times 100% para malaman natin kung ilan po yung mass fraction of the whole per element. Example, dito sa oxygen, 32 po ang nakuha natin na mass kanina. Di-divide lang po natin yun sa total mass. 32 divided by 372 times 100, we get 8.6021%. Sa nitrogen, we get 224 grams. Divide lang natin sa total of 372 grams times 100%. We get 60.2151%. Carbon monoxide, we get 28 grams. Then divide sa 372 grams. Then multiply sa 100%, we get 7.5269%. Carbon dioxide, 88 grams. Divided by 372 grams as 372 grams the total times 100% to get 23.6559%. Then, para po makuha na, then pag inad din po iyan lahat, we could get 100%. Then, para malaman po natin yung average molecular weight, we get the total mass, 372 grams divided by the total mole of 12 mole. 372 grams divided by 12 mole, we get 31 grams per mole. And next problem, sample problem number 2. Wood chips with 40% moisture as received are supplied to a biomass power plant. What is the moisture content on a dry basis? So, ito po yung sa solution natin for problem 2. Ba tayo? Wait lang. Eraser. Ba tayo? Ayan. So, ang given lang po natin is yung 40% which is the moist content as received. So, i-convert natin 40% as a whole number, 0.4. Pag sinabi po natin moist content as received, pwede rin po is equal din po siya sa moist content over mass as received. Then, next, we get first muna yung moist content dry basis. Equal siya sa moist content over mass dry basis. Then, magde-derivation lang tayo na itong mass dry basis equal siya dito. Wait lang. Ito. Kunin natin yung equivalent ni MdB mula dito sa formula na to, na mass as received is equal sa mass dry basis plus moisture content. Kaya manipulate lang natin to, makukuha natin is mass as received minus moist content. Then after that, pwede natin yung mass as received na to, i-convert natin siya dito sa yung sa kanina, di ba? Moist content as received is equal sa moist content over mass as received. Ngayon, pwede natin kunin mula dito. Wait lang. Kailangan. Kunin ko left pen ko. Mula 10. Dito. Ayan. Wala dito, kukunin natin yung value ni mass as received. Dito sa formula pa lang na to. Wala muna tayong ilalagay pa na values na number. So, mass as received, pag minanipulate ko yan, ganito, ito makukuha. Mass as received is equal sa moisture content over mass moisture content as received. So, kaya naging ganito ang kinalabasan niya. Batayaw. Wait lang. Yan. Naging moisture content over moisture content over moisture content as received minus moisture content. Then, ilalabas natin yung similar. Lahat ng similar sa kanila is the MC, the moisture content. Ilalabas natin sila para mag-cancel. Magiging 1 na lang siya. After that, yung moisture content dry basis ngayon is equal sa 1 minus 1 over moisture content as received minus 1. Yung moisture content kanina na nilabas, naging 1 na lang siya. Then, equal siya sa 1 over moisture content as received minus moisture content as received over moisture content as received. Wala naman siguro na nalabag na rules or law of kasi moisture content as received over moisture content as received equal din yan sa 1, di ba? Kasi both numerator and denominator are equal. Parehas lang, giging 1 lang din yan, di ba? Then, after that, pagkukumbala natin yung nasa denominator, ma-minus natin, then we could get 1 over 1 minus moisture content as received over moisture content as received. Since parehas lang naman ilan ang denominator sa denominator, ulitin ko, parehas lang yung mga denominator sa denominator. pwede sila, ang numerator ay pwedeng combine na lang. Then, after next, itong moisture content as received na denominator sa denominator, gets ba? You want yung moisture content. Wait lang. Then, ito. Ito, ilalagay, pwede siyang ilipat sa numerator. Sa pinaka-numerator as nahula, hindi siya yung dito. Na yung numerator sa denominator, hindi doon na. Sa pinaka-numerator talaga. Doon natin siya ilalagay. So, moisture content as received minus 1 minus moisture content as received. Ngayon, dito equal yung moisture content drive basis dito. Ngayon, may value tayo ng moisture content as received, which is 0.4. Pwede natin i-substitute, ipasok yung 0.04 para to get the moisture content drive basis equal, so 0.04 over 1 minus 0.04 times 100% equal po siya sa 66.6667%. Nakuha na po natin yung moisture content drive basis. Next, number 3, sample problem 3. The ultimate analysis of coal is given below. C, carbon equals 8.5%, sulfur equals 1.5%, ash is 12%, hydrogen is 2.5%, oxygen is 3.5%. Calculate the heating value of coal. So, dito sa problem na to, hinahanap yung heating value. Well, assume na natin na hinahanap natin is yung high and low. Kukuha na din natin siya parehas. Focus muna tayo sa pagkuha ng higher heating value. So, sinabi kanina sa to ang formula 33,820 times carbon plus 144,212 times the hydrogen minus oxygen over 8 plus 93,045 kilojoule per kilogram as the unit. Then, since given, nakasaad sa given, i-insert lang natin yung mga values ni C, ni carbon, ni hydrogen, ni oxygen. Ang value ni ang given is in percentage, so i-convert pa natin siya as whole number. So, yung 68.5%, nilagay siya as decimal, naka-decimal 0.685. Then, sa hydrogen, yung 0.025, then sa oxygen, yung 0.035, and then, 9,304 pala, I'm sorry. Dito sa formula natin sa higher heating value is 9,304 times sulfur, yung S. Sorry. So, yung sulfur natin, which is yung given is 0.015. So, doing the math calculation, ito po nakuha natin, higher heating value is 26,280.6325 kilojoule per kilogram. You get the higher heating value. Next. Wait lang. To get the lower heating value, we need is heating value minus 9 times hydrogen times 2,442 kilojoule per kilogram. Then, ito, ano lang din, direct substitution lang din, kaso sa higher heating value, itong LHV, lower heating value, higher heating value, and itong H, as received silang lahat. Then, ito, 26,280.6325 kilogram as received to, kasi yung higher heating value is as received. Minus 9, dahil, so water, divided by the hydrogen times yung sa hydrogen na 0.025 kilogram hydrogen over kilogram as received. So we cancel the kilogram hydrogen, then ito pa pala yung 2,442 kilojoule per kilogram na of water, na-cancel din yon. So ang matitira na lang is kilojoule per kilogram as received. Doing the calculation here, yan, we could get the lower heating value as received na 25,731.1825 kilojoule per kilogram as received. Next.
Next naman po is yung next sample problem. Basahin natin. Sample problem number 4. Calculate the minimum volume of data of 200 degrees API fuel having a fuel consumption of 1 kilogram per second if the temperature is 20 degrees Celsius. So, ang hinahanap dyan is yung volume ng fuel at 20 degrees Celsius. So, ano nga ba yung mga considerations dyan? We can see na yung mass flow rate niya is 1 kilogram per second. Ngayon, saan ba nakalagay yung fuel? Given sa problem, yung volume ng day tank. So, yung meaning ng day tank is usually 1 day or 24 hours. Ang tanong is, gaano kalaki yung day tank kung dapat siyang tumagal ng 24 hours kung ang consumption ng fuel ay 20 degrees Celsius. So, writing all the given, volume of fuel at 20 degrees Celsius, hinahanap natin. 1 day, 24 hours, 28 degrees API, mass flow rate is 1 kilogram per second, and ang temperature na i-consider ay yung 20 degrees Celsius. So, para makuha yung volume, meron tayong formula na density is equals to mass over volume. Dahil at 20 degrees siya, syempre ang kukunin natin is yung density ng fluid at 20 degrees. Well, hindi na natin lalagyan ng 20 degrees yung mass kasi kapag mass yung usapan, hindi niya na need lagyan ng temperature. Kasi kahit tumaas yung temperature niya, yung mass ng fuel ay hindi pa rin siya affected. Volume lang yung tinatamaan dahil sa expansion. And supported yan ng law of conservation of mass. Yung amount ng matter na nag-exist before and after change ay neither created nor destroyed. So, yung temperature na i-consider is yung 20 degrees Celsius. So, yung working formula to calculate yung volume ng fuel is yung density. Ang hinahanap dyan is yung, meron na tayong mass ng fuel. Ang hinahanap na lang is yung density. Density ng fuel, meron din siyang formula, which is yung specific gravity. Specific gravity is equals to the density of the substance over the density of water. Sa case na yan, ang hinahanap is yung density ng fuel at 20 degrees Celsius. So, kanina, may diniscuss na SG sub 15.6 degrees Celsius. Ang meaning niya is yung specific gravity ng temperature at yung specific gravity ng fuel na yung temperature, yung 15.6, ayun yung temperature kung saan siya initially nabili. So, yun yung baseline na temperature. Ngayon, alam natin na ang density ng water is 1,000 kg per cubic meter. Ngayon naman, isosolve natin yung SG niya at given temperature. So, yung una muna is isosolve natin yung store-bought temperature na specific gravity Dahil ang given sa atin is yung degree API. Meron tayong formula na degree API is equals to 141.5 divided by the specific gravity at 15.6 degrees temperature minus 131.5. So, isa-substitute lang natin yung value na nakuha natin. Makakakuha tayo ng 0.8871 na specific gravity at 15.6 na temperature. Ngayon, para makuha yung specific gravity na temperature na pinainitan na yung fuel, gagamit tayo ngayon ng correction factor. Yung correction factor is yung makikita nyo dyan na 1 minus 0.00072 minus the desired temperature ay multiplied by the desired temperature minus 15.6, which is yung baseline natin. So, plugging in the value na 20, makakakuha tayo ng specific gravity at 20 degrees Celsius na 0.8843. Ngayon, na meron na tayong specific gravity, makukuha na natin yung density ng fuel. We just have to multiply 0.8843 multiplied by 1,000. So, ang density na ng fuel natin is 884.3 kilograms per cubic meter. Since meron na tayong density, makukuha na natin si volume ng fuel. So, ang volume ng fuel is equal to the mass ng fuel, 1 kilograms per second, divided by the density ng fuel, 884.3 kilograms per cubic meter. Base dyan, makakakuha tayo ng 1 over 884.3 meter cube per second na volume. Kaso nga lang, ang
Excuse me, bakit dinivide sa 1,000 yan?
density po ng water, sir.
Yung 1,000 kilogram per meter cube?
Apo.
Okay.
Apo. So going back, dahil yung unit ng volume natin is naka-second, and ang hinahanap is volume ng day tank, which is 24 hours, kailangan natin i-convert yung seconds into days. Now, by calculation, makakakuha tayo ng volume ng fuel at 20 degrees Celsius na ang value niya is 97.7055 meter cube per days. Yan na ngayon yung sagot sa problem na gaano kalaki yung day tank na kailangan para tumagal ng 24 hours na nagko-consume ng fuel at 20 degrees Celsius. Next problem naman po is continuation lang din nung unang problem. Ngayon naman, ang hinahanap is yung heating value ng fuel na may 28 degrees API using the ASME or the Bureau of Standards formula. So, proceed tayo sa solution. By the way, yung sa solution niya, given na yung formula. Yung high heating value, 41,130 plus 139.6 multiplied by the degree API. By plugging in the 28 degrees API, makakakuha tayo ng high heating value na 45,038.8 kilojoules per kilogram. So, solving naman, gamit yung Bureau of Standards formula, yung high heating value natin, 51,716 minus 8,793.8 multiplied by the specific gravity at the baseline temperature squared. Ngayon naman, kukunin natin yung specific gravity at yung store-bought temperature niya, and gamitin na lang natin yung nakuha nating value earlier, which is yung 0.8871. By plugging in the values, the higher heating value is equals to 51,716 minus 8,793.8 multiplied by the nakuha nating value na 0.8871 then squared. So, ang high heating value niya is 44,795.7507 kilojoules per kilogram. So, take note lang dito, usually ang ginagamit sa industry is yung degree API kasi mas accurate siya compared dun sa degree BOME na na-discuss kanina dun sa topic. And that concludes our presentation about the properties of fuels, solid fuels, liquid, gaseous, and alternative fuels. Thank you po, sir.
Okay.
Teka
may,
rin.
may ano pa ba? May last sa grupo nyo tapos na yon?
Yes po, sir.
Okay. Ano ba to? Hanggang 4 ba tayo? 4:30? Hanggang ano?
4:30 po ata, sir.
4:30? 30. Meron pa ba? May magre-report? Next.
Group 4 po, sir.
Sige, handa ba?
Apo.
Sige, para ano ha? Kasi mamaya
Apo.
exam na rin tayo, mag-exam kasi nagkahabol tayo eh.
Apo.
Anong topic nyo? Ano?
Measurements of lengths, area, speed, and time.
Oh, yan. Okay lang yan. Madali lang naman pala yan.